This is my report on Lab 4. The purpose of this laboratory experiment is to examine the motion of a spring mass system in which the mass swings in an arc while also oscillating on the spring. To do this, we use Tracker to obtain the experimental model and the data, and then we use GlowScript for the computational model and the analysis of the oscillation of the mass. And the fundamental physics concepts applied throughout this experiment are the energy theorem and Newton's second law. Some errors and assumptions. Well, we assume that the spring was massless, and we only take into consideration the force of gravity and the spring force, and disregarding air resistance and other resistant forces. This is what the video looks like on Tracker. This reference dimension was given, and as you can see, this is the oscillating motion of the mass upon the spring. Tracker gives us the data, which we then use for the GlowScript computational model. For the model in GlowScript, we are given the mass of the ball, the constant of the spring, and its relaxed length. And with this and the data that we take from Tracker, we are able to calculate the kinetic energy of the mass, the spring potential energy, the gravitational potential energy, the net force, and then the velocity and position of the mass with respect to time. And this is what it looks like modeled in GlowScript. As you can see, it's the same oscillating motion that we saw on the Tracker. So this is what the code looks like. Here we have the initial conditions and the constants. We have the mass of the ball, which is a constant, the initial position and velocity of the ball, which we obtain from Tracker. Then we set our delta t. We have the gravitational constant, the spring constant, which was given, the relaxed length of the spring, which is also given, and with this information and data, we're able to calculate the initial displacement of the spring and the initial kinetic energy, gravitational potential energy, spring potential energy, and total energy. Now we then, inside a while loop, calculated the net force by just summing the gravitational force and the spring force. With this net force, we were able to update the velocity and position of the mass. And with this new velocity and position, we were able to calculate the new displacement of the spring, and then with this, we were able to calculate the new kinetic energy, the new gravitational potential energy, the new spring potential energy, and the new total energy. As for our results, the most important observation is that the delta E, the change in total energy, is 0. This is because there is no work being done in the system, and which is obtained from the energy theorem. Here we can see that when the spring potential energy and the kinetic energy of the system increase, the gravitational potential energy decreases by the same magnitude, so that the total energy remains 0. And as you can see, when the kinetic energy is 0, we have that the gravitational potential energy is equal in magnitude to the spring potential energy, but opposite in direction. And just we see throughout the graph that these energies also mimic the oscillating motion of the mass. And here we have a comparison of the computational model and the experimental model for the motion of the mass. In red, we have the experimental model, and in blue, we have the computational model. This is just to prove how accurate our model is. And as you can see, it's slightly shifted to the right in the X position and slightly shifted down in the Y position. And this is also an error that results in our experiment. This has been my report. Thank you for your time.